Is it right? He's got a pen in his hand. Hey guys, and welcome to the fifth part of Unit 4, and we're going to be talking about perpendicular lines today. So our objective is to prove and apply theorems about perpendicular lines. So remember, perpendicular lines are two lines that intersect at a 90-degree angle. And so typically there's like a little box that shows it. So the first thing that we're going to learn is which segment from point P is the shortest. Is it PA, PB, or PC? Which one is the shortest? Well, it turns out the distance from a point to a line is the length of the perpendicular segment from the point to the line. So the shortest distance between a point and a line is perpendicular to it. So like from point P to line L, the shortest distance between point P and line L is the perpendicular line. So now, what I'd like you guys to do is name the shortest segment from point A to line BC. It's AP is the shortest segment between point A and line BC because it's perpendicular to BC. Now we're going to write and solve an inequality for x. So since we know that AP is the shortest line, we know that this length has to be less than this length. So we can write an inequality. We can say that the length of AC is greater than the length of AP because AP is the shortest segment. So AC is x minus 8 and AP is 12. So we can say x minus 8 is less than, this is the less than sign, x minus 8 is greater than 12. So how I remember which one's greater than and which one's less than, I just imagine that the inequality sign is an alligator, and the alligator always eats the bigger number. So even if it was the other way around, like if it was this way, x minus 8 is less than 12, it's saying that 12 would be the bigger number. All right. So in general, we solve inequalities the same way that we solve equations. So we would just like add 8 to both sides, and we get that x is greater than 20. The only difference between equations and inequalities is like, let's say we have negative 2x is less than 10. When we divide by a negative, divide by negative 2, divide by negative 2, we actually switch the sign. So it would be x is greater than negative 5. Okay? And see, that makes sense because if we have x would be greater than negative 5. So let's say it's negative 4. Negative 2 times negative 4 is 8, which is less than 10. But if we said that it was greater than negative 5, we could, if we said that it was less than negative 5, that means it would be like negative 6 or negative 7 or negative 8, making this part greater than. So basically, solving inequalities is the same as solving equations. The only difference is that when we divide by a negative, we need to switch the sign. All right, now I want to take a look at a real-world example. So growing up, I played a lot of soccer. I was a defender. So we're going to show a soccer example. So this is me in green. Pretend like this is me. This is the soccer pitch. And the red people, the red dots, are representing 2 offensive players. So as a defender, I want to prevent them from scoring a goal up here, right? And so probably what the defender is going to, what the offense is going to try to do is probably pass between the two. Like if this person has the ball, he's going to want to pass it to this guy. So like that. Now, how do I want to defend this player? Do I want to go straight at him? Do I want to try to cut it off? Or do I want to try to kind of catch up with the ball later on? So which one would you choose? And yes, there are many other factors that go into it, but having a knowledge that the shortest distance between a point, myself, and a line, the path that the ball is going to be passed on, I might try to get to that path as quickly as possible by going perpendicular to the path of the ball. So I would choose this middle one. All right. Now, there are 3 theorems that we can kind of apply using perpendicular lines. So if 2 intersecting lines form a linear pair of congruent angles, so obviously they would be congruent because they're a linear pair, then the lines are perpendicular. So if you have 2 congruent angles that are, oh sorry, it says congruent, wow. If you have 2 congruent angles that are a linear pair, then you know that they are perpendicular. The next one is the perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of the 2 parallel lines, then it is perpendicular to the other one. So we're given that the lines are parallel, and we know that one is perpendicular. Therefore, Q must also be perpendicular to P as well. Basically, it's like a special case of corresponding postulate, corresponding angles postulate. And then basically the last one is the converse, or like the reverse, the converse of the corresponding angles postulate. So that if we have 2 coplanar lines and they're perpendicular to the same line, then the 2 lines are parallel to each other. So 2 lines perpendicular to the same line means that these are parallel. So since line R and line S are perpendicular to line T, we know that R and S are parallel. And for our last proof, our last thing that we're going to do, we're going to prove that line R is perpendicular to line T. Okay, so that's what we're trying to prove. We know we're given that R is parallel to S, so we can kind of put parallel marks. R is parallel to S, and that angle 1 is congruent to angle 2. All right, so that's given. All right, next is we can say angle 2 is congruent to angle 3 because of corresponding angles postulate. And since angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, we can say angle 1 is congruent to angle 3. And that would be transitive property of congruence. And then lastly, our last proof is that R is perpendicular to T. And this is because if we have 2 intersecting lines form a linear pair, and there are 2 congruent angles, therefore we can say that the lines are perpendicular. So since this is 1 and 3 are a linear pair, and that they are congruent, we can then say that they are perpendicular. Boom, 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 boom. All right, thank you guys. Please try the online quiz and have a good evening.